structures. Structures that are used to fix and hold solar panel in place, and we say that they are appropriate, and the appropriate design is also very essential, so that to make sure that the panels get the solar panels or the PV panels, they get maximum sunlight. They're exposed to maximum sunlight, and we say there are a number of ways. We talked about two ways where how you can mount your solar panels. About the triangular mount, and you say this one is for the flat roofs. So you mount your solar panels in a triangular design, and you have the flat roofs. And then for the inclined roofs, we say that you mount your PV panels in a flush manner. That is, they are parallel to the roof. And also we talked about the PV system layout. We say this is the how your PV system. It's a block diagram representing how components of the PV systems are interconnected. In that layout, we said we talked about the first component in the PV systems, the PV array. The PV array, we have the charge controller, the DC load, the battery. From the battery, we have the inverter, and then the AC load. So we say the PV array can supply either DC or AC loads. For AC, the power has to go through the inverter. For the DC, it just goes through the controller, and then from the controller to the DC load. We also say that this PV output can also be channeled and directed to the national grid, and this is achieved by the use of transformers. So we said in the PV array layout, so from the charge controller, you have the batteries, inverter, AC load, and then you have the generator or the transformer, so that it can scale your output, and it is able to transport. It is able to be connected to the national grid. We say national grid usually operates at very high voltage to avoid losses that comes about with the transportation of the solar system. So today we are going to go to topic 3, that is the solar system accessories. So we'll start by defining what is an accessory. So accessory, in simple terms, you can just say it is something that can be added to another in order to make it more useful or versatile. So when you talk about the solar accessories, so these are the devices that are associated with wiring. Devices such as the switch, fuse, ceiling roses are associated with wiring, the luminaires, or the switchboard themselves. So they are used to make the solar system function even in a better way. That is the first definition. The solar system, the accessory. Said accessory is those who are taking notes, it is in the whiteboard. So it's a device such as a switch, fuse, ceiling rose, or socket outlet, or a plug. There are a number. So they are saying these are devices that are associated with the wiring, the luminaires, or switchboard themselves. So once you know what is an accessory, we go to types of accessories. Four types of accessories. The first one is the AC DC switches. So the switches, there are different types of switches. So first of all, we define what is a switch. We all know a switch is a device that is used to switch on and off. But in technical terms, we say it's a device that is designed to interrupt the current flow in a circuit, or in other words, you can say it is used to make or break an electrical circuit. So when a switch is closed, then an electrical circuit is complete, and it will say an electrical circuit is closed. And when it is open, then that circuit it is open. That circuit is not complete because we don't have continuous flow of electricity. So that is a switch. We have a number of them. You can categorize them into two major types: the AC or the DC. And I want to share my screen with you so that you can be able to see uh, these types of switches. So there they are. We have these switches here. We all have seen switches at one point or the other. So these are not new accessories. You've also covered accessories when you're dealing with the electrical installation. Is a sub, like a sub unit and the general installation. So there they are, the switches. You have seen how they look. Another type of accessory that you're going to look at is the lamp holder. The lamp holder. Still, Mondo is complaining he can't get me. I don't know if it is from your side because others, I have not seen that problem with others. Confirm if you can get me in clear now, Mondo. So as he confirms, you can continue and talk about lamp holders. So we all know what is a lamp holder. It is used to hold a lamp or a bulb into its place. So the general or the accepted definition of a lamp holder is a device for securing a lamp to its position or to its support, specifically a socket or holder, and is fitted with electrical terminals into which the top of the glass globe of an incandescent lamp is fitted or from which it hangs. So you can have either the incandescent lamp or the other type of bulbs. So these devices, they secure that lamp and they hold it to its place. So that is the lamp holder. So I can give you a picture of how it looks. There we have that diagram. There we are. If you can see the shared screen. So under the lamp holders, we can have a number of them depending on the type of the bulb that you have, the type of the load that you want to attach to your holder. So we have three options of three categories of lamp holders. We have the cord grip lamp holders. The first one is the cord grip. So for this one, it's where the lamp holder includes a cord grip. It is gripping the lamp being the bulb, to secure that cord, and it is suspended as a pendant light. The common types include the compression fitting, the looping the cable around the internal obstacle, or a screw which presses the cable. So that is the cord grip. Then we have We have the other one, which is threaded type. As the name suggests, you should know that threaded threaded type. So for this one, it's where the lamp has a threaded component. You have seen those bulbs that they're not, they have threads. So you screw them into the holder. So for this threaded type is where the lamp holder has a threaded component, which is used to mount it on its support. And they are common in table standard lights where the lamp holder is fixed to the base or the stem of the lamp, and also in the conduit applications. They used to be these. They used to be called the nipple lamp holders. They used to be called the nipple lamp holders. So they have threads. And the threaded part usually come in a range of metric and imperial sizes. So depending with the size of the bulb that it will be able to hold were those threads. So it comes in sizes, and these sizes are usually measured in millimeters, maybe 14, 26, 30, and so on. So that is another type of lamp holder. Then the other one is the hooked type, number three type. So for this one is where the lamp holder has a hook for suspending using a chain, rope, or hooking over a fixture. This type of holders still also have a cord grip, the chain that secures the lamp holder, but there needs to be a device for stopping the supply cable from being pulled out. So the choice of the options depend on how you want to hang your bulb, how you want to hang your bulb, your lamp holder, and the type of load that you have. The material that are used to make these holders, they can be either metal. So there are different materials that are used to make the lamp holders. So we are saying they can be either one metal or so for the metal is usually machined from brass and available with a choice of finishes, including the aged brass or silver nickel plate. Then we have another material that can be used to make these lamp holders, that is ceramic. We know ceramic is usually molded from clay, then subjected to a bit of heat. And the other type of holder is the plastic type, made of plastic. These ones we have encountered them a number of times. So I can share that diagram that has those materials used to make the holders. If you can be able to get it. So there they are. So we have this one. This I want to believe this is the plastic type, the white one here. Then we have this type. This is ceramic, and then we have these others. These others are made of they're made from metal. So those are the major categories. Yeah? The materials that are used to finish or to make this type of holders. So ceramic, plastic, or the metal types. There are different types of metals. You can use the silver, bronze, or brass, depending with the availability and also the availability and the cost. So, So those are the that is the theoretical aspect of the holders. Next, in the solar accessories, we're going to discuss about the sealing process. Sealing process. Sealing. Yes, most of you have seen them, but they don't necessarily know what is a ceiling rose. So most of the time, these ceiling roses they are decorative, yeah? And they usually hang from the ceiling or chandelier, and the lighting fitting is often suspended from it. They are typically round in shape, and they vary in shape and sizes because they have said they are decorative. Yeah? They are ornamental. They're used to decorate your house. I want to get you their images. So there they are. I want to believe you can see those ceiling roses that I've shared. So we have these are the ceiling roses. Yeah, yes, most of the time they are typically round. Yeah? So from this edge here, this side here, this is where you fix it to the ceiling or the chandelier, and then this side, this other side, you have lighting equipment fixed there and suspended from there. So you have your bulb here, and then you have this side fixed to the ceiling. And see how it when you open up how it looks. It usually have some ports where you can attach you put in your cables, the supply, and there are different types. You can see this one is different from this one. They've said they vary in shapes and sizes, and they say they are mostly ornamental. They are mostly used for decorative purposes. Most of the time, there are basically two types of ceiling roses available, although there is a wide range of makes and shapes. The two types are the two-plate ceiling roses, two-plate ceiling rose. So one two-plate ceiling rose, and the other one is the three-plate ceiling rose. Three-plate ceiling rose. For the two-plate, it has two terminals, and also for the three-plate has three terminals. Both of them were developed for use on different wiring systems. The other types of ceiling roses were developed at a time where it was not necessary to provide an earth at a lighting point. So you find that mostly during the installation, we don't add our lighting final circuits. So when you don't have the earthing wire in lighting final circuit, then you have the two plate type of ceiling rose. But when you need to have the earthing wire, then you definitely need the 3 plate ceiling rows. It is now very essential to provide an earth, and so an earth terminal is now included on all ceiling roses. Most of the time, Duka now you get the ceiling roses or uh, the lighting sockets, which is they come with 3 terminals for the live, neutral, and earthing. This in fact means that a 2 plate ceiling rose has a third terminal fitted in it, which essentially earlier on it didn't have. So those are the ceiling roses. As we continue, you can note down if you have a question about what you're talking about, or you have something to add pertaining the same. We go to the next type of accessory, and that those are the buttresses. The buttresses. So buttresses most of the time tunasikia watu wanaziita tu kwa kienyeji the boxes, the installation boxes. Sometimes you can find them being called the buttress boxes. So it is wooden, it is made of wood or plastics. Most of the time nowadays they are made of that plastic. So we can say a buttress, or they can be also called a buttress box, is a container So a buttress or buttress box is the container for the space behind the electrical fittings, such as the power outlet sockets, light switches, or electrical fixtures. They may be designed for either surface mounting. Surface mounting, this is achieved by the cabling running along the wall surfaces, or most of the time nowadays they are embedded in the wall or the ceiling board. So when you're constructing your houses, you embed those buttress boxes inside the walls, and then from there you're able to attach your power outlet sockets or the light switches or the electrical fixtures. So those are the buttresses or the buttress. Those who have not seen one can share with you the images. The buttress boxes there they are. You can see for the single pole. So this one can accommodate just one for one switch. Then we have the for the 2 gang. This one you're to a double. So we have it here. Yeah, so earlier on we used to have buttress. Also now you can get buttress boxes that are made of metal, especially for in factories. This one they are able to withstand extreme weather conditions, but they're also not quite as safe, because you're interacting with metal, and metal is a good conductor of electricity. So when you are doing metal installation and you have these buttress boxes made of, then definitely you need to connect your earthing. You earth the boxes themselves, which is a bit of expensive, because you will need to have all those the earthing system running through the boxes. So these are the trace boxes. This one, they are quite easy. Most of you have seen them. So the trace boxes. Another type of accessory that is associated with solar installation is the CCU. I realized when you were doing the practicals, most of you they just call it CCU, but they don't necessarily know what it means. So a CCU means consumer control unit. Consumer control unit. That is what we mean by CCU. CCU. Consumer control unit. Most of us have seen them. So what is a CCU? A CCU generally can say is a subtype of a distribution board, a component of an electrical power system within which electrical power is fed. Electrical power feed provides supply to the subsidiary circuits. Subsidiary circuits, these are the final circuits. So from the main distribution board, then you have the consumer control unit, and we call it consumer control unit because the consumer who is not electrical literate and is able to operate the CCUs. So what is included in the CCUs? The CCUs, we have the switches, the RCDs, most of the time those are the main components of the CCU, and the MCBs, the miniature circuit breakers. So they are put there, and they control different types of final circuits. So you have said it is a type of distribution board, which you have said is a component of an electrical power system within which the electrical power feed provides supply to the subsidiary circuits. These subsidiary circuits are the final circuits. So from the distribution board or the DB, then we'll have the final circuits. Final circuits being that from the MCB or the RCD, the residue current breaker, the RCD, then you have your final circuit. So this can either be the lighting circuits, the power circuits, or maybe circuits that are controlling a motor that is for the battery case. So that is the CCU. This one, I believe everybody has seen it, or maybe I need to share for those who are not as conversant. So there it is, CCU. Here it is. You can see inside the CCU, we have the main switch. This is the red thing here. Then we have the MCBs. I said the MCBs, they control different final circuits. So those are the major types of accessories that are associated with the solar installation. You have seen most of them, they marry with the electrical aspect. So next we might need to discuss the types of cable joints. But before before we proceed there, I don't know if anybody has a question. Anybody with a question so far? So it seems nobody has a question. That shows we. That means I was muted. So I repeat, We're talking about the electrical power cable terminations. I say they are often designed to enable the physical and electrical interconnection of two cables, cable ends, or a cable end and a terminal of the equipment. And you say a good example is the cooker terminal. So wherever you connect your cooker to, that is right there we have a cable end and a terminal of an equipment. And we are saying that the methods that are used to terminate these cables, they vary according to the type of cable, that is the type of cable that you're using, or the type of connector. So this applies to the equipment or the application. What do you need? What is your cable terminations meant to achieve? The common type of terminations are the crimp connection, the soldered connection, compression termination, and the wire wrapping connection. So there they are, the common types of termination. They are one, the crimp connection, the soldered connection, compression termination, and the wire wrapping connection. Then the direct connection and the loop or eye connection. Those are the major types of terminations. There are a number of factors that affect how to that determine the type of termination that you're going to apply. So some of the factors that determine the type of termination, they include one, the outdoor, the use. Where are you going to use whatever that termination you're trying to achieve? So is it outdoor or indoor? Two, the voltage, the maximum voltage that your termination is able to handle. Three is the current, maximum current that can be accommodated. And then is your termination, are your cables going to run underground or overhead? Overhead ni kama hizi za Kenya Power. For the underground, this one is mostly common in the US, where you have power cables running beneath the earth's surface. And also another factor is the type of connector on the equipment where the cable will be connected. The type of connector on the equipment where the cable will be connected. So those are the factors. If you're trying to discuss factors that affect uh, the type of termination, then you name those. The use. So under use, you said it is either outdoor, indoor, outdoor or indoor. Outdoor is outside the house. Indoor is within the confinement of a house. Then the voltage and current. So these are the maximum voltage and currents that your termination will be able to accommodate. And then the other factor we said is how you're going to lay your cables. Are they going to be overhead or underground? And then the type of connector on the equipment where the cable will be connected. So those are the major factors that affect the type of termination that you're going to use. So those are the electrical terminations. Next, let us talk about the electrical cable joints. Electrical power cable joints. So the cable joints are used to connect low, medium, or high voltage cables. Used to connect low, medium, or high voltage cables. High voltage cables, these are the voltages that are rated in kilovolts. For the medium, this is like the ones that we usually use, the 240 volts, 415, those are low volts. Then for the high voltages, these are the voltages that you distribute. Like for example, the Kenya Power distributes its power with kilovolts and so on. For the low voltages, these are like the DC voltages, very low voltages. The type of cable joint sizes, shapes, and configurations, they vary according to the voltage, structure, insulation, and the number of cores of the cable to be jointed. So the type of cable joint, the size of that joint, the shape, the configuration, this one varies according to, these are the factors that affect the type of cable, the joint you're going to make. So they vary according to one, the voltages, the voltage that is able to handle, two, the structure, three, the insulation, this is the covering, and also the number of cores of the cable to be jointed. You know, we have different types of cables. Cables can be categorized with the number of cores that your cable has. So this includes when you talk about cores, this can be either single core cable or multi-core, single or multi-core cable. So those are the factors that affect types of cables to be jointed. These joints, they provide electrical insulation as well as mechanical protection and strength. The electrical connection is made in various ways, and can crimping or use of mechanical connectors or soldering be applied. We did the joints when we were doing practicals in the workshop, and we were able to make a number of electrical joints. So we can discuss some of those factors, such as the voltage structure, etc. Let us start with the voltage, and we see how the voltage affects the type of electrical joint to be used. The voltage. So for the voltage, the joints are designed for low, medium, or high voltages. We've already said this, and it is important to match the capacity of the joint to that of the cable. Otherwise, a low power cable will just fail if subjected to high current. We've already witnessed this. Yeah? You find that when you overload your cable, then it definitely will not be able to sustain or to handle all that much current. Therefore, you have your cables failing, that is by overheating or shorting, or that cable can short your whole system and you will experience a lot of losses. So that is the one of the factors, the voltage. Number two, talk about the structure. I'm trying to be a little bit slow so that the guys who are taking notes are able to copy from the whiteboard. Some of these notes, they might not necessarily have them in the notes that I will attach later on. So you might, as we are continuing, be taking short notes. And most of you are coming in very late. We have already covered 43 minutes in this class, so you might need to review the recording so that you're able to catch up with this. So next we talk about the structure. So in the structure, the cable joints, they are made according to how the cables they are to be connected. How do you intend to connect your cables? The simple joints are such as the straight through connectors. These are the just normal joints. The straight through connectors, they are used to connect two power cables at one point, where the other more advanced branch connectors may be used to accommodate a cable branching off the main line, or several cables coming into one joint from the main cable. So that is the structure as a factor that affects uh, the type of joints to be made. The other factor is what we have said is the cause. So this one affects considers the type of cable that you have. That is the number of cores your cable is made of. So I said under that we have either single or multiple cables, and the cable joints, they are required to have the same number of cores to those of the cables to be joined. So if you have a single core cable, then you might need to the other cable that you're going to make this electrical joint with, it must also be a single core cable so that it functions effectively. So the joints must have the same number of cores. The two cables or three must have the same number of cores with the others that are to be joined. The other factor is the insulation. Insulation. So, an insulation, you say there are different cable insulations depending on the application of the cable, and the cable joint must be compatible with the cable insulation. So we all know what is to insulate. Yeah? So to maintain this insulation of the jointed cables, there are a variety of insulation procedures that can be applied, and they can either be heat or cold shrinkable insulation. So this includes the use of the masking tapes. Once you have made your joint, then you have your masking tape around that joint. That is very common. Most of us have encountered this. So you join two wires and then you seal them off using a masking tape. So let us go to the specific types of electrical power cable joints. Types of electrical power cable joints. So there are three major types of cable joints, three types of joints. One, and we are during our, for those guys, so we have the telegraphic joint, telegraphic joint, T-married joint, and so there are a number of ways how you can achieve this. I want us to go through it quickly. We start with the telegraphic joint. So we say this joint is not as strong and is generally used for single core insulated conductors. So you say single coil is the cable that have just one core, one conductor inside. So we have the method. Uh, a distance of 100 millimeters. That's about 10. So you remove the insulation, 10 centimeters, clean the ends. Then if it's a VRI cable, you strip off the braiding and tape for a further 12 millimeters on each conductor. That is step number 3. And then you cross the conductors about 30 millimeters from the insulation, keeping the left hand conductor in front. Then using pliers, you grip the crossed conductors together, then twist the left hand end and the right hand main portion together. And this stance needs to be not to be sharp, and this is to avoid mechanical damage to you or to the user. Then next, you twist the right hand end and the left hand main portion together. Then cut off surplus conductor ends on the bevel with side cutter, and then you smooth over with pliers. So this is to make your joint to be smooth and to avoid those sharp ends. Then the last step is usually to solder the joint. Solder the joint, and then you wipe off any excess solder with a flat cloth pad, and then make good insulation removed. So that is how to make the telegraphic joint. I'm going to share some videos for those guys who are not able to attend the practical classes to be able to see how to do this. You can try this at home. Just get two conductors that are single core and try to follow this how you come up with it. Next, so once you have made it, this is how it will appear. So this is the telegraphic joint. We also said it is also called the American twist joint. So you can see it is a single core cable. So at both ends, that is why you have the continuation of your cable. So you said you first strip off those, you strip off the cable. So you can see you twist them. Then after you've made this type of joint, you can see this cable is the one that has these coils here, and this other cable is the one that is having or coiling around there. So they coil at both ends. So after you've made this cable joint, you put in you solder the joint. So the other joint that you're going to talk about is the T-married joint. So this one you're going to just talk about. I don't know what is happening today with my sound. I don't know if you can get me clear, Miss Madam Wairimo. Can you? So as she confirms, you can continue with the other joint. That is the T-married joint. The T-married joint. Let me share the screen with you. So there it is. So we have the method how to make this T-married joint. It is also called a three-stranded conductor. So there it is. So first of all, just like the telegraphic joint, you remove the insulation from the through piece for a distance of about 50 millimeters. Then if it's a VIR cable, we said VIR means the vulcanized Indian rubber. So if it's that type of cable, You strip off the braiding, 12 millimeters at each side. It's about 1.2 centimeters. Then you remove the insulation of the T-piece at a distance of about 75 millimeters from the end. Then, still if it's a VIR, strip off the braiding and tape a further 12 millimeters. Twist the strands of the through piece and then twist the T-piece in the direction of lay for about 25 millimeters from the insulation and twist the remainder the length of the piece and straighten the strands. And then you offer the T-piece to the through conductor so that the strands are made to go round to the left hand side of the through piece and also and the strand round the right hand side of the through piece. You tighten the strands in their respective direction, cut off the surplus strands on the bevel and side cutters. You smooth over with pliers, and then once you have that joint, you solder it and you remove excess solder with a flaxed cloth pad. I want to believe you have copied that. So let us look at this clip that shows us how to make this three-strand joint. So that is the first step, the stripping off of the conductor. You strip off your conductors. Talked about the size, the size that you're going to distance. All that is stripping off. So you join your three strands. Once you join three strands, you twist them over each other, both the left hand side and the right hand side. So once you roll all the two sides together, you can see already what is formed here is the T, is the joint, which is T in general. So for this cable, this is a multi-core cable. If you're going to use a multi-core cable, ensure the other strands are also multi-core cables. Once you are through with that, you solder your joint. I don't know if anybody has a question so far. Most of you are joining late. If anybody has a question, you can ask before we conclude the class. Your mics are enabled. You are able to talk if you have a question to ask. See, Francis is typing. You can also use your mic if you're not able to type faster. Francis, you're waiting for you to finish typing, asking if the class is for term 3. This is like a common unit for both the DEE and CEE, both the September and January intake, and anybody else who feels interested with the solar installation. I hope your question is answered. The class is not specific for any group. It's for all electrical engineers who are doing solar installation. We combined all of you to one class. Any other question? If there is no any other question, then we finish the class at that point. So enjoy your time and keep safe. We meet next time. Next time, if you are joining the live session, ensure you come early so that you don't miss a large portion of the class. So there are some notes I've attached. Ensure you go through them. So have a nice day.